So this next question that in bending moment topic. So that is a numeric answer type question. So in this question that just see the figure that at full draw an archer applies a pull of 130 Newton to the bowstring of the bow shown in the figure. Determine the bending moment at the midpoint of the bow. So just check that we are applying the pull force this side, because when you apply the pull force, so by this one tension in the cord, so we have to calculate the bending moment at the midsection. So that at this midsection, this part, we have to calculate the bending moment value. So now check that when you apply this pull this side and this pull given 130 Newton we apply. So we apply this side 130 Newton pull, that is a 130 Newton. So when you apply pull this 130 Newton this side, so that tension will develop in the cord. So we know that one tension, one cord, one tension. So you can cut the section, you can cut this side, you can cut this side. One cord, that one tension. And when we can draw the free body diagram this part. So this side that is a 130 Newton, 130 Newton. And this cord that this side tension T and this side tension T. This way. So angle given that is 70 degree. So we can find out the component. So that component T cos theta this side. That 70 degree angle, 70 degree angle. So that will be T cos 70, T cos 70 plus T cos 70. So we can write down first equation that 2T cos 70 that equal to 130 Newton. So by this one T will be that equal to 130 divided by that is a 2 cos 70. So we will put all values finally, that final calculation. So we have this tension value, that's this tension that in the cord. Now check, we have to draw the bending moment diagram. So that we have to calculate this bending moment value at this section, because that is a 2 marks question. So we can make the free body like beam given. So beam we for in between let we have to find out bending moment or shear force. We cut section, just one side we can balance, we can calculate the value. Same way that we have this T value tension. So we just cut this part, we cut section in between. This point we cut section. So let's just check this way diagram. And this tension will be T, that this T, because we cut this side. So this will be tension upward side T, and this way downward side T, this way. So we cut this side T, and we have this angle 70. So this angle, so this angle will be also that 70 value. So just we draw the free body diagram this portion. Let this point A, this point B. So AB part we cut. Just we check the AB part. So this AB part and this tension T this side. This tension T this side. Now we find out the component. So this for component 70 angle given. So this will be that is a T cos 70. And this will be that is a T sin 70. This one. And this in between part we cut section. This will be that A point, this B point. So B point that in between we have to calculate bending moment value. So distance all given, all distance is given. So you check this total distance that is a 1400. So this distance will be this distance that will be 700 mm. And this distance will be given that is 350 mm. So we can find out distance, we can find out moment value. So check this distance, that distance will be 350 mm. And this distance will be that is a 1400 mm, 1400 by 2 that is 700 mm. So this point we cut section, we can find out bending moment value. So let's decide that is a Vx and this Mx. So we have to calculate this Mx value. So we can easily find out that Mx value. Now check this two component. This point you put the pen. So T cos 70 and this vertical, because moment we know that force into perpendicular distance. This point you put the pen. So T cos 70, this one into distance 700 mm, that is anti-clockwise. And this T sin 70, that this distance 350 mm, that anti-clockwise. So we can find out Mx negative value. So finally that is Mx, that we just check the magnitude. So that is the T cos 70. So T cos 70 into distance, that is 700 mm, that 700. And plus that is this one T sin 70. So T sin 70 into distance, this one force into perpendicular distance, that is the moment. So T sin 70 into 350 mm. So T sin 70 into 350 mm, this one. So T value we have, this T value that is 130 divided by 2 cos 70, this value. So just put the value T. So T that is a 130 divided by 2 cos 70 cancel up, and this final, that is 700. T value is the 130 divided by 2 cos 70. Cos 70 that cancel up, 130 by 2, that's 700, and plus T sin 30. T is the 130 by 2. So 130 by 2 and sin 7. This is sin 70, not 30. That is a sin 70. So that is a sin 70, not 30. Why? Because that is a this value T cos 70, this is T sin 70 into 350 value. So 130 by 2 sin 70 cos 70, that is a 1070. This one, that is a 1070, and this one, that is a 350. So T tension, that T value given. So that T value is given, that T is the 130 kilometer. This one T value, that this T value 130 by this total. So we just put the value 130 by 2, 1070. We can easily find out because calculator we have. So we put the value and this calculation. Final we find out moment. So moment finally that we can find out. Just we put the value 1070. You can find out that final moment value, and that final answer is the 108. That when we calculate this one, 108 Newton meter. This way that all calculation. So by this giving pulling force, by this pulling force, that cord will get the tension, and we cut section. So we get that we find out tension in the form of 130 this way. Then we cut section, this T. So T cos 70 sin 70. Just we find out the moment this point. So this one, that is a on GATE examination numerical answer type question. So that because we have multiple choice question, multiple select, numerical answer type, and some one good full concept question we are solving. This is a numerical answer type question, that total calculation. So that is a good question.